So the hz of a linear time invariant system and the discrete time system is given, and you have to find the relationship between a1 and a2 so that it represents a stable as well as a causal system. Okay, now in the time domain, the z transform, inverse z transform of hz is hn impulse response, and this is equals to 0 for n less than 0. This is the condition for causal system. Okay, now if the system is stable, then it must include the one radius 1 circle. Okay, so if it include radius 1 circle, for example this one, this ROC is basically include radius 1 circle, so this is basically for a stable system. Okay, now for this type of hn, it's represent basically your right hand side signal. Okay, because hn is 0 for, if it is hn, so hn is 0 for n less than 0, so it basically represent some right hand side signal. Okay, and we know for right hand side signal, if you draw the z transform in z domain, then it must be outside of the outermost pole. Okay, so let us assume it has, suppose for example this 4 pole, so it will be the outermost pole, outermost region of the outermost pole. Okay, so this is basically the your ROC for the causal system. Okay, ROC for the causal system. Now let us see our transfer function. So this is our transfer function hz, so we can multiply z square in both sides, so it will be z square divided by z square plus a1z plus a2. Okay, and this polynomial is you can find the location of the poles from this polynomial. So location of the poles will be zp, for example. So this is basically minus b, that is minus a1 plus minus root over b square minus 4ac, a1 square minus 4ac is a2 by 2a, means simply 2, a is 1. Okay, so this is the location of the poles. Okay, we have basically two poles, p1 and p2. Let us assume zp represents the location of the poles. Okay, now so suppose this is jet plane. Okay, and this is radius 1 circle. Now in order to have this causal as well as the stable system, the pole, location of the pole must be inside this z equals to 1 circle. Okay, because then only it will include the radius 1 circle. Okay, and as well as it will be outside of the outermost pole, that will represent and then it will be a causal system. Okay, so the value of this zp, or in general you can say zp, is must be less than 1. Okay, because this is radius 1 circle. So what you can write, you can write it as this quantity as minus a1 plus minus root over a1 square minus 4a2 divided by 2 is less than 1. Then you can multiply 2 in this side, that is a1 plus minus root over a1 square minus 4a2 is less than 2, and then take this quantity, that is minus a1, to this side plus a1 and square on both sides. It will become simply a1 square minus 4a2 is less than, so it will be 4 plus 4a1 plus a1 square. So you can cancel a1 and a1 from here. Okay, so you can cancel 4 also. Okay, so it will be simply minus a2 is less than 1 plus a1, right? And you can see you can multiply minus on the both side. Okay, so it will be a2 is greater than minus 1 minus a1. Okay, so this is basically represent a1 plus a2 is greater than minus 1. So this is the condition, that is a1 plus a2 is greater than minus 1. If this condition is satisfied, then only you can say that the location of the poles are inside this mod z equals to 1 circle. Okay, so that will represent your causal as well as a stable system, right? So this is our first condition, that is a1 plus a2 is greater than minus 1. Okay, now let us assume that this a1 square minus 4a2 is less than 0. That time it will represent a complex number. Okay, so assuming your a1 square minus 4a2 is less than 0. Okay, so a1 square is less than 4a2, right? Okay, now what we can do, we can write it as minus a1 plus minus j, that means root over minus 1. Then we can write it as 4a2 minus a1 square divided by 2. Okay, divided by 2. So this quantity now is positive. Okay, means 4a2 minus a1 square is greater than 0. Okay, this quantity is positive. So this is basically the complex root. Okay, now you can write it as minus a1 by 2 plus minus j under root. You can write it as a2, and it will be minus a1 square divided by 4. Just bring this particular 2 inside this root. Okay, now what is the value of mod zp? Mod zp is basically your under root this quantity, means minus a1 by 2 whole square, that means a1 square divided by 2 plus your square of this quantity, that means a2 minus a1 square divided by 4. So you can cancel this 2 term. So this is basically root over a2, right? So this is basically your mod of jp, right? Now mod of jp must be less than, this must be less than 1 in order to the poles inside this radius 1 circle. Okay, means mod zp mod z equals to 1 circle. Okay, inside this circle. So you can write it as a2 is basically if you square both sides, then a2 is basically less than 1. So this is another condition, right? Now you have to also include this condition. Okay, this one, that is your a1 square is less than 4a2, right? And a1 square divided by 4 is less than a2, and a2. Okay, and a2 is less than 1, so you can write it less than 1. It is less than 1. So this is the relation, so which imply that a1 square divided by 4 is less than 1, or a1 square is less than 4. So you can say that a1 is less than 2, right? So a1 is less than 2 and a2 is less than 1. So the next condition from the option I can see, okay, so we can take a1 minus a2. Okay, a1 minus a2 is basically 2 minus 1. Okay, a1 minus a2 is basically less than 2 minus 1, that is 1. So this is the third condition. Okay, a1 minus a2 is less than 1. So first condition is this one, and the second condition is this one, and third condition is this one, that's a1 minus a2 is less than 1. So option D is correct. Okay, option D is correct.